Today we will see how to obtain an equation, a recursive equation, to integrate sine nth power x dx. This n right here technically could be any positive integer. Usually the recursive equations are used for large values of n. Alright, now because of this n right here, I'm going to label this integral as I sub n. For example, if I had to integrate sine 10th power x dx, in that case I will have to label this guy as I sub 10. Alright, next what I'm going to do is I'm going to split this sine nth power x into two pieces so that I can apply integrations by parts. So I'm going to rewrite this in as integral sine n minus first power x times sine x dx. Next, I will identify the components necessary for integrations by parts. I'm going to need a u and a dv. I cannot integrate sine n minus first power x straight away. Therefore, I'm going to label that as the function to be differentiated, or in other words, as the function u. Sine x can be easily integrated. Therefore, I'm going to label that as dv. Once those two are labeled as that, the integrations by parts require us on the right hand side of that to be u times v minus integral v times du. Alright, let's keep that in mind. In will now be equal to u times v. U is equal to sine n minus first power x. dv is equal to sine x. Therefore, to obtain v, I need to integrate sine x. If I integrate sine x, I get negative cosine x. So I'm going to write that negative symbol right here and cosine x. And the integrations by parts require us to have the negative symbol afterwards. Minus integration v. Once again, dv is equal to sine x. To obtain v, I need to integrate sine x, which is negative cosine x. Because of this negative symbol right here, all outside will become positive, and there will be a cosine x inside the integral. And that times du. Du is, we know u is equal to sine n minus first power x. To obtain du, I need to differentiate that term. Therefore, it will be differentiated as n minus 1 times sine n minus second power x times cosine x. That cosine x will be combined with the available cosine x right here and write it as cosine squared x dx. I wrote down this n minus term outside because n minus 1 is a constant. Alright, now I have this cosine squared term. That cosine squared term, I'm going to replace that with 1 minus sine squared x. That's from the Pythagorean identity from trig. And then what I have to do is I will have to multiply sine n minus second power x with each of these two terms of 1 minus sine squared x component. On the left hand side I have I sub n. On the right hand side I have minus sine n minus first power x cosine x. That plus I have n minus 1 integral when 1 is multiplied by sine n minus second power x, it will become sine n minus second power x. And I will have a negative symbol, and then I need to multiply sine n minus second power x with sine squared x. The powers will be added and it will become sine nth power x. Outside I have dx. Alright, now this integral can be split into two integrations. On the left hand side I have I sub n. On the right hand side the first term is negative sine n minus first power x cosine x. And then I have plus n minus 1 times the first term right here is integral sine n minus second power x, which I can write as I sub n minus 2. And then I have this minus symbol. I'm going to write it right here. And then I have another integration of sine nth power x. Sine nth power x is I sub n. Alright, now I need to distribute that n minus 1 into these two pieces. Let's do that. I sub n is therefore equal to negative sine n minus first power x cosine x plus n minus 1 times I n minus 2 minus n minus 1 times I n. Alright, now we will take this negative n minus 1 times I n to the left hand side. Then I have I n plus n minus 1 times I n being equal to negative sine n minus first power x cosine x, that plus n minus 1 times I n minus 2. Alright, now we can simplify this left hand side. On the left hand side I have 1 I n and also negative 1 times I n. Those two will be cancelled. Therefore I'm only left with n times I n. N times I n is now equal to negative sine n minus first power x times cosine x plus n minus 1 times I n minus 2. Now to isolate I sub n, I need to divide both sides by n. So when I do that, I get I n being equal to negative 1 over n sine n minus first power x cosine x plus n minus 1 over n I n minus 2. Now this is the recursion for integrating sine nth power. Let's say for example, we need to evaluate the integral sine 7th power x dx. In that case, I need to identify this as I sub 7. Alright, our task is to find I sub 7. Now, according to this equation right here, I sub 7, when n is equal to 7, the right hand side should be negative 1 over 7 sine 7 minus 1 is a 6 x times cosine x, that plus n minus 1. When n is equal to 7, n minus 1 is a 6, that divided by n is 7. I n minus 2, 7 minus 2 is a 5. Alright, now we need to continue. We have negative 1/7 sine 6th power x cosine x plus 6 over 7 I5. Now I need to apply this recursion once again with n equals 5. Let me open brackets. I5 will be equal to negative 1/5 sine 4th power x cosine x plus 4 over 5 I3. Alright, we will do some simplification right here. I have negative 1/7 sine 6th power x cosine x, and I'm going to multiply these two terms. When I multiply those two, I will have a negative 6 over 35 sine 4th power x cosine x. And then I need to multiply these two terms. When I multiply those two terms, I get plus 24 over 35 times I sub 3. Now we can apply the recursion for I3 right here. What was the recursion again? The recursion equation we had was I sub n equals negative 1 over n sine n minus first power x cosine x plus n minus 1 over n I n minus 2. So I'm going to apply that equation once again for I3 with n equals 3. Negative 1/7 sine 6th power x cosine x minus 6 over 35 sine 4th power x cosine x, and that plus 24 over 35. I will open brackets and apply this recursion with n equals 3. It will be negative 1/3 sine 3 minus 1 is squared x cosine x, that plus this term 3 minus 1 is a 2 over 3 I 3 minus 2 is 1. Alright, now I need I sub 1. I sub 1 is integration sine x, which is negative cosine x. Alright, now we are all set to write down the final answer. I sub 7 should be now equal to negative 1/7 sine 6th power x cosine x minus 6 over 35 sine 4th power x cosine x, and then I need to continue with these two. Those two terms should be multiplied. 24 over 35 times negative 1/3. Once those two are multiplied, I get negative 24 over 35 times 3 is 105 sine squared x cosine x, and then I need to multiply 24 over 35 times 2/3. When those two are multiplied, I get positive 48 over 105 I1. I1 was equal to negative cosine x. Therefore, this symbol right here should be changed to negative cosine x, and then there will be a plus c. Alright, that's the final answer for the integration of sine 7th x. Alright, I hope you enjoyed this video. If you would like to try the recursion, here's a homework question for you. Integrate sine 10th power x dx. But I need to give you two guidelines. Before applying that recursive equation, please make sure that you derive the result. Derive the result in being equal to negative 1/nth sine n minus first power x cosine x plus n minus 1 over n I n minus 2. This was a recursion for sine nth power of x, and please make sure to derive this equation using integrations by parts. And after that, you have to select n to be equal to 10 because this is 10th power of sine, and then you can repeatedly apply that equation and see if you can obtain the answer. The second point I need to make is this equation right here has I n minus 2. That means we are going to subtract 2 in each iteration from 10. Therefore, there will be a moment where you have I0. What is I0? I0 is integration sine 0th power x dx, which is integration 1 dx. This is equal to x. All right.